Hello all, welcome to Omega Codex, where we talk about programming, software design, cloud DevOps, and other interesting topics in software development. My name is Sanal, and this is the third and final part in the series of health checks in .NET Core. If you haven't watched the previous videos, I would recommend you to watch it first. You can find the link to the first video here. If you're new to the channel, please consider subscribing by clicking the subscribe button below. Before we get started, let's do a quick recap. Moving on from health checks, we understood how to make it work with some specific host names and port numbers. We also looked into how to make it secure using authorization. Then we added tags using which we can filter health checks and run only a specific set of checks. We also customized the response of the health checks to give out more detail instead of just returning healthy, degraded, or unhealthy. Then we created health check publisher, which lets us push out the result to a desired location. We sent it to the console, but you can also send it to a monitoring service, an API endpoint, or any other suitable destination. In this video, we will cover about health checks UI, some more integrations which are available with health checks, and then we'll jump to the other end and try to consume these health checks using some of the Azure services. So let's get started. Welcome back. The first topic we are going to discuss is HealthCheck UI. HealthCheck UI is a minimal UI interface that stores and shows the HealthCheck results from the configured HealthCheck URIs. To integrate this HealthCheck UI, we'll need to add the HealthCheck.ui services and middlewares, which is available in the package HealthChecks.ui. So let's add those required packages first. We will add 3 packages for this. The first one is ASP.NET Core.HealthChecks.ui, then HealthChecks.ui.client, and a storage, HealthCheck storage. So we will be using in-memory storage for this example. There are other storage providers also available like SQL Server, MySQL, and others. So now that we have added this, let's go and set up our HealthCheck UI. So to set up the HealthCheck UI, similarly, we'll have to add the middleware, and that is HealthChecks UI. And like we did for map health checks, we will have to set up app.map.healthchecks UI. What this would do is it will add a default UI under the path HealthChecks UI. The minimal interface which it provides, it's basically a single page application with a default interface which shows your health check results in a nicely formatted way. Just run it. We haven't fully set it up, but let's check out what comes out as the result. Okay, we forgot to add the storage. Yeah, this is important. We'll have to add in-memory storage. So if we go to our UI path, we'll see the basic interface being popped up. For now, it is showing up blank. So it's not showing any results here because we haven't wired up our health checks to this UI. So we will have to make that connection to see some result here. So let's go back and do that. So this method add health checks UI, it takes a parameter which is ui.configuration.settings, which is an action. Let's set that up. In settings, we have add health check endpoint. So let's call it default. Let's give it a name and let's point it to our default health endpoint. Now let's run it and check. So we have our result here, which is coming up as unhealthy, but we don't have any details here. So for that, we will need to add one more thing, and that is the customized response. So in the previous videos, we had discussed about the response writer, which is available as part of health check options. And here it is currently wired up to custom response, which we had implemented in the previous video. We will need to replace it with a UI response writer, which is part of health checks UI. So that's the delegate we are going to use to write out the response. Now if we go to checks UI, we can see a much detailed version of the health check status. So our application health check is healthy, SQL Server health check is unhealthy because the client ID from which I am running is not allowed. So the SQL Server I'm using is an Azure SQL and my IP is not in the allowed list. So that's why it is showing up as unhealthy. So this way we can set up a nice UI for our health check statuses and we can display it in a better way. There are some additional properties which we can play with in health check response. There's something called a set evaluation time in seconds, which is the polling interval and how much frequently you want to check the health check status, and you can mention that in seconds. Another one is set minimum seconds between failure notifications. You can also set up webhook notifications in health checks UI. You can come here and add a webhook notification. You can give a name, then the URL and payload which you want to send. Payload is basically a string which would contain a JSON or any information which you want to send. Then there is a restore payload which you can set up when you want to send a resolved notification. So there is another way to set up this configuration, and that is in your app.settings. So in app.settings, you can set up the configuration like health checks UI, and there you can define your health check endpoint. So these are like additional endpoints which you want to set up if you have an external API which you want to check. We had previously done that using an application health check in program.cs. We had set this application health check which was essentially doing the same thing, but you can also add other endpoints in this health check configuration, so it would also perform these health checks. For now we'll remove this and we'll just set up the webhook here. Here I have set up this webhook configuration and I have set up a mock API on Postman which is called health check notify, and I have set up the payload which I want to send. So the payload has few properties which we can use. So one is this liveness descriptor, then there is a failure, and then there is description. So these three are provided as part of your health check UI. The liveness mentions which health check went down or which health check failed. It's the name which we provide here in the name property, or even when we define the health check configuration here, the name value which you give is the name which comes here. Failure mentions about the failure happened, and the description gives more description about the failure. So these three tag descriptors we can use in your payload message, which would give more information about what failed. So this webhook notifications are helpful when you want to send your notification to endpoint or say to a Teams channel or to Slack. So in that cases you could use this webhook notification. So here we have set up part configuration in app settings and part in our code. Let's see how it works. So you can see our health check is still running from the configuration we have done in the code. And when we go to webhook, we can see the webhook that is configured. So this is the message format which we have defined, and this is our description format. Let's go to our Postman, just refresh this, and we can see that we got failure notification, and the request body we have the details. So the message is default has failed. Default was the name which we gave to our health check. The failure description is there is at least one health check failing. So that is something which is internally provided by health check, and this was the text we mentioned. And in the description we have which health check is failing. So SQL Server health check is failing. Instead of this payload, say suppose you want to send it to a Teams channel, Teams provide message cards which is a JSON structure, and you can define the values in that message card, and that JSON can be put up here. You can also customize this health check UI. This map health checks UI takes configuration options. We have something called as add custom style sheet, which lets you add custom CSS if you want to make it in line with your application's UI. You can have a page title, you can set up the UI path, so you can play around with these configurations and customize your health check. So that's about health check UIs. The next topic we will check is more on other integrations available. So we'll look into some more integrations which are available. We'll just quickly go through those. There are a lot many integrations available as part of health checks where you can integrate it with available services and systems in a very easy manner. So here we had done an integration with SQL Server. There are similar integrations available for Azure Storage, Azure Service Bus, Storage Queues, Key Vault, and not just restricted to Azure services. The integrations available for Amazon S3, Amazon SNS, SQS. Then there is Azure's Cosmos DB, Kafka, Kubernetes, MySQL. So there are lot many middlewares available, ready-made, which you can use to do health check on these services. So I'll put a link for the reference in the description about this. So let's quickly check out few of them, how we can set it up. So I'll just add some code to make it quick. Let's add packages one by one for each of them. For Azure Blob Storage, we will need a package called healthchecks.azure storage. For Service Bus, it's Azure Service Bus. Then healthchecks.cosmosdb, and the last one is Azure Key Vault. So for Azure Blob Storage, I'm providing the connection string to the blob storage or the storage account, and then the container name and a name for this check, Azure Storage Blob. Then I have an Azure Service Bus queue check here. You have similar options available for Azure Service Bus topic. So if you have topics, then you can do a check for that. So what it essentially does is, it will, using this service bus connection, it checks if this queue is available and can push or pull messages from that. It's helpful in that way. Same as with your Cosmos DB, you have a DB connection. If you want to do specifically for a database, even that property is available, you can mention the database name and it would check if that database is available. Azure Key Vault is a particularly nice one. If you are using Azure Key Vault integrations, it would check for specific secret. There are options available for add certificate, add secret, add key. So you could do an instant check that this secret is available. The only thing is, with Azure Key Vault, there's no connection string. You have to use an Azure credential. Using a default Azure credential, you can run it. So let's run it. Our health check has come out, and let's see what is the status. So unhealthy we were already getting for SQL Server. Our storage check came out fine, Service Bus also fine, and Cosmos DB also fine. But our Key Vault check shows up unhealthy because our authentication failed. That's how we can set up additional integrations. So I just wanted to show a few integrations which are commonly used. The final section, let's jump to Azure and try to consume these services using some of the Azure offerings. So I have deployed our sample application to an Azure App Service with all the integrations which we discussed earlier. And now if we go to the health checks UI, we can see all our health checks are returning healthy. So now my SQL Server is also healthy because I'm connecting it from an Azure service and it is enabled to work with Azure services. And also my Key Vault is working because I have given my app service access to the Key Vault on Azure. Now, one place we can use our health check endpoint is health checks in the app service. So if we enable it, we can just give this endpoint as health and save it. Now here we can go to the metrics and see the health check status. It is at 100 and it is working fine. So this health check in app service is useful when you have set up the scale out feature and you have more than two or more than two instances available. So if an instance returns unhealthy status, any status other than from 200 to 299 for consecutive 10 checks, so every check happens in 1 minute interval, and if for continuously for 10 times you receive unhealthy status, so that instance is removed from the load balancer. The health check would continue to check the health status of your instance for another 10 minutes until it is deemed unhealthy and it is removed from the load balancer, and it would restart that instance and run it again. So this is one place where we can consume our health check endpoints. Another place where you can consume your health checks is in Application Insight. So Application Insight is the APM service, Application Performance Monitoring Service. So here you can go to availability and create an availability test. So here we will give a name, and the URL we want to check is our health check endpoint, and frequency we have set as 5 minutes. It would also do an SSL validity check. So if your SSL is expiring, it would send you a notification. And what this availability test does is test your endpoint from different locations around the world. So you can select many of the Azure locations from where you can test it, so that it checks your availability from different locations around the world. Minimum recommended is 5 locations, so you can select more also, but at least 5 is the recommended number by Azure. And we'll keep the alert status enabled, and we can create it. And see, my availability test is created. It will take some time to show up the availability status, and you can see that now it is showing up as 100%. Now let's go to Azure Monitor and check our alert. We have an availability test created for our health check sample web app, and it is set when the failed location is greater than 2. So we have set 5 locations for availability test, and when the health check from at least 2 or more locations fail, then the alert would be triggered. So if you are not familiar with Azure Monitor is a service provided by Azure which helps you in maximizing your availability and your performance of your applications. And there are different ways to collect, analyze the telemetry collected from different Azure services. Alerts is a mechanism in Azure Monitor which lets you send notifications in case there is a failure. So you can have different levels of severity defined for your tests or your alerts. So in this case, for availability test, we have set up a error alert, and you can have a notification group where you can send out notifications. So it can be an email, it can be an SMS, it can be any other format if you want to send it to a webhook. So different options are available. Now let's go back to our app and stop it. Let's go back to alerts and see if something has come up. Let's switch to when alerts get generated. So it took few minutes for the alert to come up. So now we have our alert fired, and we can see the details of the alert. This is another way where we can set up proactive monitoring using the health check endpoints and generate alerts when your application goes down, and you come to know immediately. So one more place where we can use is in Frondor. So Frondor is a load balancing service provided by Azure, or one of the load balancing services available in Azure. So I'm not changing any configurations here, and just where we can set it up. Let's put it as backend, and I can select my app. So Azure lets you, based on the service you are selecting, lets you easily pick up your service. So here in the health probe, you can define the health endpoint. In an ideal scenario, you would have more than one backend host. Since we only have one instance or one app service configured, we have added one, and which is of not much use. But in an ideal world, you would have multiple app services hosting the same application, and you can add additional backend hosts. The health probe is configured for all of them. So when a load balancer checks these health endpoints, it would check the health endpoint of each of the app services, and whichever is returning unhealthy, the traffic will be diverted from that backend host to other available backend hosts. Until that backend host becomes available, the traffic will not be routed to that host name. So here you have options to check head and get, and based on the interval you can set how frequently you want to probe this endpoint. And then there are some load balancing options like sample size, successful samples are required, and latency. So these you can configure. So I'm not explaining this because it's not a front door video. Maybe I'll explain it in some other video. This is one more use case where these health check endpoints are useful. So these were some of the services which I just wanted to show where we can use our health check endpoints. With that, we have come to the end of this series. We have covered most relevant topics related to health checks. If you have any questions, please let me know in the comment section below. I will be happy to help. If you have any suggestions or topics you want me to cover, please let me know that as well. I hope you have enjoyed this series and it helps out in your development journey. If you liked the video, please click the like button and please do subscribe and hit the bell icon so that you get notified whenever new videos come out. That's it for today. See you in the next one. Adios. By the way, don't forget to check the book suggestions in description. There are some cool ones there. Once again, adios.